In the perfectly brittle case, we can describe the failure region as the union of three disjoint regions. And these three regions are actually quite revealing, and it might aid the analyst for a much more complicated situation to proceed systematically through a sequence of member failures. So let's look at them one by one. The top block marked 1 gives the situation where unit 1 fails first, followed by unit 2. So R1 is not able to carry the load alpha P. So R1 is less than alpha P, and then because it's brittle, the entire load goes over to R2, the second member, and it's also not able to carry that load, so R2 is less than P. So together they define the region marked 1. Likewise, the region marked 2 is when unit 2 fails first, and that has a similar logic to it. The region marked 3 is interesting. It is that situation where 1 and 2 fail simultaneously in some sense, and so there is no scope of redistribution. Each member is weak enough so that it's not able to carry the load given to it in the intact stage. Now let's define the symbols on the right part of the equation, the right hand side. F01-2 means failure starting from intact condition. 0 means no element has failed, so that's the intact state. And then in the subscript we have 1-2, so 1 fails first, followed by 2. Union, we have F0 in the superscript, 2-1 in the subscript. So it's the same logic, starts from intact case, followed by failure of 2, and then failure of 1. And the last one is F0 subscript 1-2. As I said, that is both of them fail together, and when the system is in intact state, and we are going to expand that in terms of 2 events very soon. So let's expand F01-2 and see what events actually it is composed of. And this approach is going to help a systematic structural analysis of an increasingly damaged system. So let us look at the 3 events in the first set of curly brackets. So it is F01, F02 bar, meaning the complement, and F12. So let's see what they are trying to say. F01 means in the intact stage, member 1 fails. That's fine. But to be able to claim that unit 1 fails first, we also have to specify that unit 2 does not fail first. So that is where the F02 complement comes in use. So F02 complement tells us that in the intact state 2 isn't failing. And then once 1 has failed, the third event gives the next condition that in the state that 1 has failed, in that damaged state, 2 is the next member to fail. Likewise, the second set of events inside the curly brackets gives the region 2, which is unit 2 fails first, and the third event we have so far kept intact, F0, 1 and 2 kept unchanged, but we are going to expand that also in a few seconds. So what we do next is we have 3 events, A union, B union, C, and we just, for convenience or for a certain purpose, we are going to do A union C or B union C. So we bring F0, 1 and 2 along with the first set of curly brackets. And now it's logical to say that F0, 1 and 2 is simply the event, the intersection of F01 and F02. Why? Because all we are saying is that in the intact state, 1 fails, and in the intact state, 2 fails. So that's why there is no scope of redistribution, no analysis of a partially damaged structure, F0, 1 and 2. So with that explanation, let us look at the first term within the square brackets, and that is F01 and F02 bar and F12, the whole thing, union with F01 and 2. And now bringing in the expression for F01 and 2, we find that F01 is the common event in the 2 sets that have the union. So we can take that common out and express that as the intersection of F01 and another 2 sets. And then we also see that in those events inside the square brackets, we have F02 complement and F02, so the same event and its complement. So it further simplifies to the union of F12 and F02. Now that event, that union, saying that F2 fails, that 2 fails after 1 or 2 fails in intact stage, it basically means 2 fails. That's all. So if we interpret that and give a symbol that it's F subscript 2, then we can define the first set of events as F01 intersection F2. Likewise, the second term becomes F02 intersection F1. So our system failure event could also be expressed as the union of 2 events, not union of 3 events. And obviously you sense the difference. When is the union of 3 events, as we have in the top, it's 1 or 2 or 3. These are all disjoint sets. So in some sense it might be easier to analyze them. The probability of the union of disjoint sets is simply the sum of the probabilities, so it might be easier. On the other hand, F02 and F1 or F01 and F2, these events might be easier to conceptualize and to analyze a damaged structure. So in some sense, even though they are not disjoint, it might be easier from a structural analysis point of view to define failure that way. So we are not giving any preference at this stage. We are just giving both options which can be used by the analyst depending on the situation. So now we are ready to define the system failure. As I said, when we have the union of 3 disjoint sets, the failure, the probability of the union is just the sum of the individual probabilities. So that's what you see. And now we are able to bring in mechanics and define the 3 disjoint sets in terms of the loads and the member strengths. So just going through the steps, F01-2 is the same as R1 less than alpha P and R2 between 1 minus alpha P and P. Likewise, you get the second term, and the third term, which is F01 and 2, is R1 less than alpha P and R2 less than 1 minus alpha P. So together, these 3 terms can be computed and we can find the system failure probability. As I said, we could also equivalently define system failure as the union of 2 intersecting sets, and in the end we are going to get the same answer. So we express F6 as P of F01 F2 plus P of F02 F1 minus the probability of the intersection. And if you go through the steps carefully, you end up with the sum of two probabilities and a subtraction of the intersecting area. But in the end, they will give you the exact same answer. Again, depending on which one we do, we choose depends on the particular structure and how easy it's to analyze one way or the other.